Hello everyone. In today's session, we are going to discuss regarding the force and force system in engineering mechanics. In earlier lectures, we have seen the various fundamental statics which are associated with the engineering mechanics. So, the system of forces in engineering mechanics has been divided into various parts. The first one is a coplanar concurrent force system. So you can see this force system where various forces which are passing through a single point, which are passing through the single point, and the line of action, you can see this line of action of all these forces is passing through the same point. So this point is called as a point of concurrency. This point is called as a point of concurrency. So when coplanar forces or the line of action of the various forces passing through the single point, that is called as a coplanar concurrent force system. Now you can see in the second one, coplanar non-concurrent force system. So various forces, this force F1 or this force F2, F3, F4, they are acting at the different point. Their line of action, if you see that their line of action, okay, those are not passing through the single point. You can see here also line of action of the every force is different. In fact, these are coplanar but acting at a different points. So that's why this system is called the coplanar non-concurrent force system. Then when line of action of all the forces are parallel to each other, then that is called as a coplanar parallel force system. So you can see whether the forces are going upward or coming downward, whether the forces are going left or right. So their line of actions are parallel to each other. So that's why it is a parallel coplanar force system. Then when number of forces are acting along the same line and the line of action lies in the same line, then it is called as a collinear force system. So you can see all the line of actions are passing through the same point. Then let's see some laws of mechanics. In the first one is the law of transmissibility of forces. The state of rest or motion of a rigid body is unaltered if a force acting on the body is replaced by another force of same magnitude and direction but acting anywhere on the body in the line of action of the replaced force. So you can see this is a body. The force F is acting at this point A, but this force can be transferred in this line of action provided the latter point is within the body itself. So forces can be transferred in the line of action. So you can see this particular trolley system. So where this is a push type force is there, but we can transfer this particular force from this point to this point. Okay, but in this case this will be a pull, and here this will be a push type force. This will be a push type force. Then let us discuss regarding the resultant and equilibrium force. Resultant force, it is possible to find a single force which will have the same effect as that number of forces acting on a body. Such single force is called as resultant force. And equilibrium, it is the force which is equal, opposite and collinear to the resultant of a force system is known as equilibrium of force system. You can see this number of forces is P1, P2, P3, P4. These four forces acting at the point O. So if you replace all these four forces by a single force, that force is called as a resultant force, and opposite of equal magnitude, collinear, that force is called as a equilibrium. Then resolution of a force. The process of splitting up the given force into number of components without changing its effect on the body is called as a resolution of force. A force is generally resolved along the two mutually perpendicular directions. So you can see this force P, which is making angle theta with the x-axis. So this is to be splitted into the two components. So horizontal component is called as a Px, and which can be calculated as a P cos theta, and the vertical component Py, which is called as a P sin theta. So how this can be obtained? You can see. So this force P is making angle theta with the x-axis. So we have made the construction. We drop the perpendicular here, and this side is AB, BC, CD, and this is DA. So these two sides are same here. You can see. Okay. So in this angle ACB, so if you see here, right, so this horizontal component is called as a Px, and the vertical component is called as a Py. So initially I would like to tell you that this particular AB is equal to this CD, right? So if you see the triangle, this ACB, and if you take the sine theta, it is this AB divided by AC, that is hypotenuse. That's why AB is equal to AC sin theta, but AC is P itself, and CD, you can see CD is nothing but the, you can see this particular, okay, CD is here, this is PY. So it is the vertical component is Py is equal to P sin theta. Similarly, from the same triangle, cos theta is equal to this BC upon AC. So BC divided by AC, BC is this Px, and Px is equal to AC is nothing but this force P itself. So Px is a horizontal component. So remember, so this particular force, this is horizontal component. Now if you see in all the quadrants, so you can see this is first quadrant, second quadrant, third quadrant, fourth quadrant, and this force P1 is making angle theta 1 with the x-axis. So its horizontal component, which will, now all the forces are acting away from this central point O. Let's call this a point O here, origin, from the origin. So if the force is acting away from the point, the components will also act away from the point. So this horizontal component, which will act from this point, which is given here as a plus P1 cos theta, because it is going towards the plus sign, and the vertical component will act in the upward direction, right? So that is given here as a plus P1 sin theta 1. In the same way, in the second quadrant, this P2 is making angle theta 2 with the x-axis. So horizontal component that will act horizontally here towards the negative sign. So that's why it is given minus P2 cos theta 2. Vertical component will act in the upward direction. So which is shown here. So which is plus P2 sin theta 2. In the same way, this theta 3, P3 is making angle theta 3 with the x-axis. So downward component is minus P3 sin theta 3, because the vertical component will act in downward direction here. Horizontal component of this P3, that will act towards left from this point. So that is again shown here, which is going towards the negative side, minus P3 cos theta 3. Similarly, this P4 making angle theta 4 with the x-axis, horizontal component will be plus P4 cos theta 4. Similarly, vertical component will act in the downward direction from this point. So that is shown here, which is going towards the negative side. So shown here as a minus P4 cos theta 4. So that's all for today. Again, in the coming sessions, we will see regarding the various aspects of the force system, its implementation, how to find out the resultant force, etc. Thank you very much.